All right, we're going to move into section 9.3, the chapter review problems that are on page 611. Okay, so with these problems, we're going to go ahead and work on adding and subtracting radical expressions. Quick thing that you should know when we're adding and subtracting radical expressions, it's really important, just like when polynomials and stuff like that, you need to have like terms. Since it's a radical expression, we need to look to have like radicals. That means that they have to have the same index, which means the root. So for example, here you have the cube root. This would only be able to be combined with something that is a cube root. And they have to have the same radicand, which means the same exact base. So what's inside the radical has to be the same as well. It's the only way you'll be able to combine those. Now you can manipulate and you can simplify to make them the same, and that's actually what we're going to do later on, okay? But let's start off with an easy problem. This is example 1, letter B from section 9.3, so you can go ahead and work that one out too. I'm going to work it out here on the paper. It's really simple. If you keep this in mind, to keep like radicals, you'll be able to do this easily, okay? So let's go ahead and let's look here. We have 6 and square root of x, 6 square root of x minus cube root of 4 minus 5 square root of x plus 2 cube root of 4. So we can see right off the bat that we have two different types of radicals here. We have the square root of x and we have the cube root of 4. Here you can see square root of x and another square root of x, and then here you can see the cube root of 4 and another cube root of 4. We're only going to be able to combine this one with this one and this one with this one because they're the only ones that have the like radicals. So let's go ahead and do that. Let's start with what I underlined in blue, and we're going to do them separately, okay? We're going to start with 6 square root of x minus 5 square root of x. 6 square root of x. Now, important here when you're dealing with these radicals, treat them as you would any other variable, okay? So pretend that this was like a y. 6y minus 5y would give you 1y. So just like that, this would give you 1 square root of x. And let's go ahead and work the other one. You have a negative cube root of 4 plus a 2. Let's go ahead and do that. Remember to include that sign at the beginning. Really important. Don't forget it because you will mess up. 2 cube root of 4. Same exact thing. If we were to replace this cube root of 4 with y, we have negative y plus 2y, or the actual term is negative cube root of 4 plus 2 cube root of 4. That's just going to be 1 cube root of 4. Again, please don't ever forget to write that cube there if it is a cube. So they're both positive in the end, so when you add those up, your final answer will be, and I'll go ahead and write it under here, you'll have square root of x plus cube root of 4. And that's your final answer for this first one here. And you can go ahead and check it in your books. That is the final answer. Let's move on to this one down here. Now this one's a little bit different because as you can see, we don't have any radicals that are exactly the same. Okay, so we don't have any radicals here that are exactly the same. So we're going to have to simplify. Now remember in the last video I told you guys some rules for simplification. I'm going to go ahead and write them up here even though I'm covering some stuff up. Some simplifying radicals rules. Okay, first is that all possible nth power factors have been removed. No fractions and radicals and no radicals in the denominator. 2 and 3 are not anything that we see in this problem number 55. So we're going to focus on number 1 is that all nth powered factors have been removed. That just means that it's simplified as much as it can be. Let's go ahead and work these out. So let's simplify. How do you simplify 2 square root of 24? 24 does not have a square root, right? Nothing times itself equals 24. But we can break this up, okay? We can break up 24 into its prime factors. Now remember, prime factorization, the easiest way to do it, if you can't think about it right away, how you can break it up so that you can get something that can be square rooted, we're just going to break it up into its prime factors by using a factor tree. So let's go ahead and do that. So we have 24, the factor tree, when in doubt, divide by 2, right? So we have 2, 12, 2, 6, and then 2 and 3. So these are all of your prime factors. Okay, so your prime factors here. Now, what are we going to do? We're going to write all of these as multiplication inside of the radical right there under 24. Okay, so we're going to have 2 times the square root of 2 times 2 times 2 times 3. Okay? And some of you guys may remember what the next step is to do here. Basically, what you're going to do is you're going to look at whatever the root is, and whatever that root tells you is the groups that you're going to make. So you're going to have to make a group of 2. The first group of 2 that we see is right there, 2 times 2. So we're going to rewrite this, right? 2 square root of 2 times 2, which is 2 squared, times the square root of 2 times 3, whatever was left, which is just 6. Okay, so this 2 times 3, we could have written it 2 times 3 here, right? But we're just going to combine it, skip a small step, move it into this square root of 6, okay? So now we have this, which means we can simplify even further because we know that the square root of 2 squared is just going to be 2. Since this becomes a 2, 2 times 2 is just going to be 4, okay? This square root of 2 squared becomes 2, so then 2 times 2 is 4, so here you have 2 times the square root of 6, and we've just gone ahead and simplified square root of 24 into 2 square root of 6. We multiplied it times the 2 in the front, and it becomes 4 times the square root of 6, okay? Let's move on to this one here. This one, actually, there's really nothing that you can do here, right? This is as simplified as it can get. It's 7 times the square root of 6. 7 times the square root of 6, we see that the square root of 6 can't be simplified any further. So this one just goes straight down, okay? We're adding this 7 times the square root of 6. Now let's move on to the 54. And 54, we know that we can simplify it. And just to skip a step and make some time, why don't you guys go ahead and make the factor tree on your own for 54, okay? Do the same thing that we did for 24 here, but once you do that, you'll see that you'll get a factor where you can have, and let me go ahead and write it here, where you'll have the square root of 2 times 3 times 3 times 3. Okay, and since it is a square root, what you're going to do is you're going to find a group of 2. Well, here we have a group of 2. So you can rewrite this as the square root of 3 squared, and then whatever's left over, which is the square root of 6, right? 2 times 3, that's going to be 6. This becomes this, and then these two become that, okay? Square root of 3 squared is just going to be 3. Okay, so 3 times the square root of 6. And now here you can see down here in the bottom that now we have a problem that we can simplify by using the like radicals. Each one of them have the same index, which is square root, and the same radicand, which is 6. Okay, so now we can actually combine them. We treated it like if it were any other variable. 4 times square root of 6 just is actually 4 square root of 6 plus 7 square root of 6 minus 3 square root of 6. So if you combine those, 4 square root of 6 plus 7 square root of 6 minus 3 square root of 6, what are you going to get? Simple math, right? 4 plus 7 is going to be 11. So that's just going to be 11 square root of 6 minus 3 square root of 6. And 11 minus 3, we know it's going to be 8. So your final answer is going to be 8 square root of 6. Okay? Pretty simple. The only step I didn't do was making that factor tree for 54. So make sure that you do that. Make sure that you take the time to make that factor tree for 54. Okay? Just so that you can get this that was inside here. Okay, so let's move on to the last one so we don't make this video too long. 2x cube root of 24x squared y minus cube root of 3x to the 5th y. Okay, simplify, same exact thing. We're gonna try to focus on this part right here before we can combine these. We can't combine them, right, because they're very different inside the radical. The radicands are very different. They do have the same root, they have the same index, so we're good with that, but we need to get them to have the same radicand. So let's go ahead and do that. We can kind of ignore this 2x in the beginning. Let's go ahead and focus on simplifying that 24x squared. And if you guys remember, the best way to simplify that, just how we had it last time in the product and quotient rule, we're going to break these up, right? By using the product rule, we say that we can break these up. Okay? So we're going to break them up into their own individual radicals. Okay? So here, we're going to just rewrite this 2x, and then we have times the cube root of 24 times the cube root, don't forget that cube root of x squared, times the cube root of y. Okay? And then we'll worry about this one later on, but let's focus on this first one here. The cube root of 24. We kind of just did the same exact thing up here, right? We don't need to redo the factorization of 24 because we already made our factor tree up here. So here we have the cube root of 24. We're just going to break that up just how we did before. Rewrite this 2x. It's going to be times the cube root of whatever 24 breaks up into. So 2 times 2 times 2 times 3. All right. But in this case, we're going to be looking for groups of 3. Different from up here, we were looking for groups of 2. But down here, we're just going to be looking for groups of 3. So your group of 3 is going to be here, these 2's, right? So you're going to rewrite that down here as 2x times the cube root of 2 cubed, right, times whatever is left over, which is the cube root of 3. And we'll come back to this part next, okay? Remember that this is going to be multiplication with now the x part, which is right here. Okay, so sorry that it's getting a little sloppy. I'm running out of space. But the cube root of x squared, how do we do that? Cube root of x squared, well, guess what? If we were to break up this x squared into multiple things, the only factors that would be are x and x. And there's no way that you can get a group of 3 when there are only 2 x's, okay? They do not match up. So since they don't match up, we know right off the bat that this right here is just going to stay as the cube root of x squared because there's nothing that we can simplify there. We can't take out 3 x's from something that only has 2 x's. So this is just going to be the cube root of x squared. Let's move on to the next one. Okay, so this one, the cube root of y, same exact story, right? We can't take out 3y's from something that only has 1y, okay? So this is just going to stay as the cube root of y, and we'll rewrite it down here as the cube root of y. Okay, so this all stays exactly how it is right there. We're going to rewrite it up here later on, but let's just make sure that we know that this is the semi-final simplified version of this first part right here. Let's do this part now, okay? Same exact thing. We use the product rule to tell us that we can break up the coefficient and the variables. So let's rewrite them, and we'll rewrite them here. The cube root of 3, you guys can probably already think what's going to happen with that when you try to simplify it. The cube root of x to the 5th. Now, since there are 5 x's, we're going to go ahead and write them all out. So here you have your 5 x's. We wrote them all out. We're looking for groups of 3. Here are your groups of 3. So there are 3 x's there. So let's go ahead and rewrite the next part. Let's finish here. And then the last part is the cube root of y. Same exact thing right here, right? We can't take the cube root of y. So when we simplify, this cube root of 3 stays the same. The cube root of x cubed, that's what you're going to get here now. The cube root of x cubed times the cube root of x squared, right? This can't be simplified, but this one definitely can. And then the cube root of y, that one's not going to be able to be simplified either. Okay, so I know it looks different, but this is the semi-final simplified version. Okay, I'm going to take this out so we have some more room to work. All right, and now we're going to move on over here. We're going to go ahead and rewrite. So put these two together, and we're going to go ahead and move on right here. We're going to go ahead and rewrite this right here, but let's simplify it, okay? 2x stays the same, right? So we have 2x. The cube root of 2 cubed, these are going to cancel out, okay? These are going to cancel out, and that's just going to be 2. So times 2 times the cube root of 3 times the cube root of x squared times the cube root of y. Okay, so that's the first part there. Now we can simplify this further and we can combine these like terms. Okay, they have the same radical, they have the same index and the same radicand, so we're going to combine these like terms. This is multiplication, so we're not combining. Okay, forget that I said that. This is different. That's for the subtraction and addition. Okay, this like radical stuff is just for subtraction and addition. All right. In this case, we can merge these three together because of the product and quotient rule. Product rule tells us that when you have different products with the same root, you can put them all under the same one, and that's what we're going to do. Okay, so we're going to go ahead and rewrite this into, combine these two, right? On the outside, that's going to be 4x, and then combine everything that is in the radical together. So we have a 3, we have an x squared, and we have a y. Okay, so this is this first part right here. Let me go ahead and draw a better arrow. That's that. Okay, now let's go ahead and let's do this one right here. Forget that I wrote this arrow, and we're gonna go ahead and do this one. I'm sorry that it's getting so messy. Should have planned this better. Let's go ahead and do this one right here. You have the cube root of 3. Okay, and then you have the cube root of x cubed. Those are going to cancel out, and that's just going to be x. You have the cube root of x squared. Can't do anything about that. And then you have the cube root of y. Can't do anything about that. Now we can simplify this into x, right? Because x is the only thing that's not in a radical, and then we'll put everything in the radical afterwards, which is 3x squared, right? 3x squared and the y. Now, if you remember, the problem originally was a subtraction problem between these two. All we did was simplify these two, right? We simplified these two things into this. So let's rewrite the problem as 4x, the cube root of 3x squared y minus x times the cube root of 3x squared y. Now here we go into the adding and subtracting rule for like radicals. Okay, since they have the same index, right, the same root, they're both cube root, and now they have the same radicand. We simplified this to be like this, and we simplified this to be like this, so that they can have the same exact radicand. This and this, both radicals are the same, which means we can combine them. So we're going to combine them. 4x minus x. Basically, all you have to do, treat this radical as if it were a variable. Okay, so let's think of it as, I don't know, u. Okay, this whole thing is just going to be treated as a u. This whole thing is just going to be treated as a u. 4xu minus xu is just going to be 3xu. Okay, so here you're just going to have 3xu. But remember that the u actually stands for something else. So our final answer, we're going to plug that in. You have 3x, and then the cube root of whatever was in the radical, which is 3x squared y. And then this is your final answer. Okay, pretty messy. I'm so sorry about that, but this is the first part of 9.3.